welcome friends once again to my NPTEL MOOC module on exploring healthcare data, healthcare survey data as part of the Minister of Education's initiative of NPTEL program, where so many unique courses are being floated. I have tried my best to contribute to this gap in different courses given the challenges of physical education. This time we have considered the model on healthcare. The course outline is on healthcare, understanding healthcare data. These are called healthcare data analytics as well. Here we are dealing with the 7th week lectures. On the 7th week, we have already taken 2 lectures. Here we clarified about what are called panel data, how to understand or read panel data, how to know balanced and unbalanced panel data. In the previous lecture, we talked about common constant model or pooled panel model. So even if it has panel content, but that is regarded as a cross section type. This lecture we are adding feathers to the existing information on panel, that is a dimension called effect, fixed effect model. I am just clarifying the overview of it. Fixed, the word fixed effect means in the multidimensional setup with time and cross sectional variation as part of the panel structure of the data. Some variables by structure are defined to be changing with a fixed percentage, with a fixed component, fixed coefficient. The fixed coefficient may not be captured in the slope coefficient. Slope, the change is not exactly captured, but the constant term could be actually identified as the change. Like when you say your consumption pattern in every year, it might be hardly changing with different variables. If your location is getting changed, I am just giving various type of examples. Location is changing, your attire is changing, your you are putting a new dress, for example. Your consumption is not going to change much. Even if your income is also changing, the extent of consumption is changed with certain degree due to certain dimension of the product. Some of the consumption is a function of income, and income change has reflection on consumption for sure. But there are some parallel example in this case, though you are a bit confused with this. Some parallel example like person's height over the time due to as a factor of various as a function of various factors, or consumption as a person's caste, for example, caste over a period of time. Caste, religion, etc. within a family is not going to be changed over time, or over a period of time it's not getting changed much. But when you just try to capture the time effect, probably you are not going to identify the exact aspect of the change. But that does not mean it is not changing with a structure. The alpha, that is the constant term, is somewhere reflecting the standard of living of the person. No, it not though exactly capturing the variation in terms of time, but there might have been a paradigm shift which is captured in terms of a constant term, that is alpha. So that is where the panel data stands, and the panel data clarifies through the fixed effect on the constant changes, on some unit of V top in change in the constant term, not by the slope coefficient. That is why we are dealing with this particular lecture and emphasizing on the fixed effect of panel content. And this is going to be very interesting in your everyday work, especially those who are targeting for topmost journal, topmost paper, panel data used to be very important, to icing your model, to give a better direction in your model, to have a better interpretation so far as policy recommendation is concerned. That is one direction I said. Then second aspect is whoever is doing some kind of analysis using the large scale data, large scale cross sectional data, but it has time component as well. It is a kind of micro data, but the time time horizon is very less. It is a kind of short panel, not a long panel, where your cross sectional dimensions are there, but not with by the time. Okay. So, cross sectional dimensions are obviously capturing certain variations, certain dynamics. Okay. So, within effect is not so much significant, but between effect might be there. So, that between effect and within effect clarification I gave it in the previous lecture. So, that aspect you can easily capture through the fixed effect model. Okay. So, fixed effect model is of course useful in research, and I suggest strongly that you please follow between the line, between the space, between the subscript and superscript, and understand very clearly, and you will enjoy like anything. Okay. So, let us go ahead and clarify the equation once again, starting with the very basic fundamental equation of the panel data. The dependent variable is with the subscript I and T, that you can easily see. I am clarifying bit by bit and give you the right direction. You might not have received this particular information from my previous year's model and previous model on handling large scale data. I did not explain much, but now I feel that based on the feedback of the students, I feel that re-emphasis should have been there on each of the coefficients, starting with the fixed content, then with the then with the slope coefficients, etc. Now you can see that this beta term is not going to change much. It's constant. So that means our by slope dimension it is not identifying the changes, but overall the model is going to capture the certain dimensions in terms of cross sections are captured in the constant term. Okay. Therefore, it has certain assumptions. Okay. So, the same equation is further elaborated as alpha. So, beta is beta 1 plus beta 2. This is not beta I, each of the beta coefficient is now estimated with its control variables. And these are all our control variables, and this is our error term, and error term is of course attached with each of the dimensions, cross section dimensions as well as time dimensions. So I just said that the slope coefficients are going to be constant, but the intercept varies across individuals, not across time. Time component is not varying the model as such significantly, rather it is differentiating the model with its alpha term. But in the common constant model, alpha is actually constant. In the cross sectional model or even the ordinary least square model, you could have noticed that alpha is not alpha I. Okay. Here alpha is observed because of the panel content. On the aggregate, when you have a data, all are cross sections, there is no question of a same persons is indicating or giving certain views over time, but the same persons when repeated, even if you are considering minus the t term, but the same persons have certain cross sections as well, cross section variations within the time period as well. So that is why the alpha term is actually capturing the dynamics of the cross sections. Okay. So in the earlier cases, alpha term does not consider the dimensionalities of its cross sectional changes. The above model allows each cross sectional unit to have a different intercept term through all slopes, though all slopes are the same. That is what is called individual effect. Okay. Alpha is in fact called individual effect. Each individual's dimensions are actually captured, and this captures the omitted variables. If there are any sort of variables omitted by a random procedure or by non-random procedure, in both the case omitted variables have a possibility of dropping or possibility of deletion, that is actually captured through the individual effects. That is why it is called alpha I. So, the most important aspect for all of you to note is omitted variable bias are actually captured in the case of fixed effect model, and that we have no knowledge of for one reason or the another about capturing this individual effect, and that is captured. The what is this alpha I? Alpha I in fact is a proportion of the alpha, that is through Z I. Okay, Z I is actually unobserved, and since it is unobserved, considered to be correlated with the explanatory variables. Okay. So, that is why there are some problems with the OLS model. So, normal OLS model are not going to be applied, since the Z I is correlated with the explanatory term. In the fixed effect model, the individual effect or specific effect is a random variable that is allowed to be correlated with the explanatory variables. Fixed effect model and analyzing the impact of variables that vary over time. Fixed effect model explores the relationship between predictor and the outcome variables within an entity. So, each individual and its effects are actually captured, that is why we say within an entity, and that is actually occurred due to the time changes, time dimensional. Though time wise there are no changes, but in individual case there are expected to be some variations. So the assumption in the specific individual effect is correlated with the independent variable, that is why the covariance of alpha I and XIT is non-zero. Okay. And then this is a serious error in OLS, so OLS is not applied. So, the methods for estimation of the fixed effect model is made through two approaches. One is through LSDB model, that is famously called LSDB or called least square dummy variables approach, and the second one is called within effects approach. Okay. Now, we are going to experiment with the LSDB approach to take certain variables to be with a dummy content, with a dummy variables model, and we will clarify how those problems can be avoided, and then we can apply for an OLS model. Okay. The LSDB model incorporates the individual unobserved effects via dummy variables into the model. The least square dummy variable model allows for heterogeneity among subjects by allowing each entity to have its own intercept value. Okay. So, through the dummy variables, each entity to have its own intercept value. Let us consider the model once again. This is equal to beta times XIT. So, beta is constant here, but now other two terms are alpha I and I.I.T are actually having certain variability, but T is not there. So, T if I say it is actually not there. Okay. So, T component is not there, but variability is observed through the individual variations, and due to the what is called if some unobserved effects are not captured. Okay. So, that can be captured through the alpha I. Although the intercept may vary across subjects, but does not vary over time. So, that is the reason why it is called time invariant model. This is also called time invariant. So, there is no T term attached with the alpha I. Okay, that is why this is called time invariant. So, the LSDB estimator is actually called a pooled OLS, including a set of n dummy variables. This identifies the individuals and hence an additional n parameters, since we are adding dummies, n dummies. Okay. So, n parameters are again generated. Nonetheless, this formulation does not suffer the problem of dummy variable trap, since it contains no intercept. We have already read earlier about what is called dummy variable trap. If you take parameters as compared to the number of categories, if they are same, then it is going to have certain problems in the model. That kind of problems of estimation is called dummy variable trap. So, dummy variable trap is avoided depending upon the alpha content we are taking, like in the first equation YIT is equal to the first beta 1 till xi term. Now the alpha unit is expressed into a number of dummies, since alpha is not there. So that one is gamma times 1, d 1 I, first I is captured, then the second like one xi, no, x2 I, x3 I, etc. Here we are defining each dummies till n dummies to replace that the alpha I, just to identify its coefficient, so that we can estimate the right coefficient in this model. If using separate intercept term, then since intercept is there, and so n minus 1 dummy has to be considered to avoid the dummy variable trap issues. Okay. Then there will be any, if you do not consider then dummy variable trap is actually explained through the multicollinearity problem, and multicollinearity is going to give you 1 as the value, because that there will be a perfect multicollinearity. If you have some difficulties here to read the dummy variable trap, I suggest you to read the simple textbook called by Damodar Gujarati. It will give you the right directions as well to explain you dummy variable trap correctly. So in this one, when we are considering the alpha as the coefficient alpha term, then basically that since this is there, to avoid dummy variable trap, we have considered n minus 1 dummies. Okay. So n minus 1 dummies, then each of the estimation is going to give you the correct prediction of the model. So this type of model is also known as one way fixed effect model, because only the intercept is allowed to differ between individuals. So since intercept term is now actually allowed to be estimated through different intercept, that is why called one way fixed effect. So obviously there will be two way fixed effect model. In that case, time effects can be also incorporated with the individual effect. Okay. So like the model including n plus t dummy variables as well, if time effects are also captured. So without the intercept, then there will be n plus t minus 2 dummy, because now we have time dimensions as well. So first of all, when time dimensions are there, this is our basic model. Now this is without the time. So till n, now you can see this is continuing to this till n without the alpha term. Now we have the time dimensions. Okay. So since so dummies are considered to be defined n minus 1 and n minus, in this case n minus 1 and t minus 1, and so this is basically equal to n plus t minus 2 dummy variables. All right. With the intercept term, if you are including the intercept term. If we do not have intercept term, then it will be of simply n plus t dummy, because intercept term is not there. This equation basically is without the intercept term. So this equation, the dummy variables are n plus t minus n minus 1 and t minus 1, that is n plus t time minus 2 dummies are there, and accordingly we have captured each of the differences. So this is called two-way fixed effect model. There are some advantages and disadvantages. Advantages are it has simplified the model. Disadvantage is that there are too many dummy variables. If you have a pool of cross sections, so many cross sections are there, then you might have so many dummy variables that lead to loss of degrees of freedom, and this may not be able to identify the impact of time invariant variable. Many dummy variables will lead to the problem of multicollinearity. So that is there. Now I am also explaining what is called the within effect estimation. Within effect, first we have explained about the concept called LSDP, what is called least square dummy variable model. We will have practical sessions. Once I explain this within effect estimation, I will go for the practical session, or add certain results with the original data, and will clarify. The LSDP model is feasible to implement when number of cross section units are small. Okay. When number of cross section units are large, then it is better not to use the LSTB, rather to use within group effects model, that is through the within effect model. We eliminate alpha I by expressing the value of the dependent and explanatory variables for of each of the individuals as deviations from their respective means. Okay. When we know that the individuals are not actually varying, some of the variables are actually not varying much or not at all varying. Some characteristics of panel data, that some of are not varying over time. So, if you just deviate their mean value from the individual entries, then that will be defined, that will be considered to be having 0 variation. So, most of your variables are going to be having 0 values, and that way we can avoid many of the problems in the model. So, the equations as per I just addressed is that this is our first panel data with slope coefficients are constant, and then this is the constant term with certain variations, cross sectional variations. Now, we are trying to take the averages, average over time, okay, over time of each of the explanatory variables. Now, what it is going to give us is that this is your average x bar 1 I, then 2 I, then ki. All right. So, this is also average over time. Okay. Now, we have taken the difference between the first equation and the second one. So, here it has next equations clarify what is this average. Average is basically over the time only, t tends to 1 to t in each of the cases, and you can find out the average accordingly. The resulting values are called d mean values or time means at each unit I. By each unit I, we have actually derived the mean values. So, next step is for us to subtract these two equations from 2 to 1. Okay. So, 2 is our or 1 to 2 from we are subtracting from the equation 1 to 2, 1 is here, and subtracting these two. What is going to give us is that like we have taken Y.I.T minus Y.I.T minus this Y.I bar. So, in each case we have got the difference, right. Now, what is interesting is that if there are no such changes in the constant term, especially when we know that it is having certain fixed effect, okay, fixed within effect is fixed. Okay. In that case, alpha I and alpha bar is going to be 0. When this is going to be completely 0, then rest of the equation is simply of our OLS type of model. Okay. It is simply having beta constant values or beta coefficient having no further changes within it or dynamics within it. So, we will simply estimate the beta values. Okay. So, it is not beta I, it is only beta as a beta 1, beta 2 and beta k. So, each of the parameter we can easily estimate, since now alpha is avoided. Now, we will therefore use the OLS in the equation to estimate the parameters. One of the disadvantages of the model is that this is time invariant variables. Some of the time invariant variables are wiped out because of differentiating. Even xi, we say x1 till xi 1 I bar, x2 I bar, etc. It may be case that one of these coefficient might be wiped out because of its constant variation. All the variations are constant for the same categories or same variable. So, that value will be also difficult to estimate because that is time invariant. So, another disadvantage is that this method is creating some problem in terms of differentiating. When we differentiate a variable, we remove the long run component from that variable. So, the long run the time component is actually completely also wiped out. So, the time dimensionality is not going to be interpreted at all in this model. So, now we have the practical examples, and we are trying to show you the results with the help of the data. The data set and variables are used similar in all three models, that is CCM, fixed effect as well as random effect. Random effect model we are going to go, deal with in our next lecture. At this moment we are comparing CCM and FE. FE stands for fixed effect. Now, you might be confused that how to get this data. If you have a data, how to develop a panel. I will be using WHO as well as ISDS panel data. We have already shown you how it is defined to be panel, and whether it is strongly a panel or strongly a balanced panel or not. Okay. Rest of the details you want to develop your panel data, you can refer to my module that was earlier developed, that is called handling large scale data set with Stata. So, the Stata command to run fixed effect and random effect is your XT regression. XT is often used in case, it is used in case of panel data estimation. Before using ST or EG, we need to set Stata to handle the panels. We need to set the Stata, we need to set or set the Stata with the command XT set to set the Stata about, to recognize the Stata about your data, whether it is panel or not. So, we want to also understand whether it is a balanced one or not a balanced one. Okay, we can still run the model for unbalanced panel data with certain missing observation as well. Now, here are all our commands, and I am going to show it one by one. We will also compare the fixed effect using LSDB model, then comparison between CCM and LSDB fixed effect model as well. Now, let us even in the next one, it will be within effect also would be also captured. So, let us go for it and then clarify. Here is the data being loaded on your screen, and we are taking the Excel data provided by the WHO example data set. It is a balanced data as per the WHO. We will also test that as well. We recognize its variable ID variable as the first row. Now, we will also show you the do file that is considered for the analysis, and in the do file we will be experimenting with the commands and give you the direction. Now, through the through the WHO data set, we have already explained you about the CCM model. CCM model, I said that how simple OLS is drawn. But once again we will read this data with Stata. XT set should be made first, because XT set will recognize your data as strongly balanced. You can see that the data is from 93 to 97. Okay. Now, we will be also running the model as per this need. Regression, we have already made the results earlier for CCM. Now, we are clarifying for LSDB model. So, LSDB LSDB model is run on your screen. You can see how many time component the dummy variables components are generated, okay, for the to replace the alpha term, okay. And so, number of degrees of freedom is accordingly reduced, as I already mentioned. All right. So, that is one of the wrong disadvantage of this data set. So, dummy variables, the way we explain, there are so many dummy variables created. You can easily see this. 33 dummies are there. Okay, 32 dummies are there. From one is the base category, then other dummies are there. Okay, so constant term is also there. So, n-1 dummy has to be created, as I already mentioned, since 34 is the n in the model. Okay, so -1 is created. 32 dummies are actually created. So, and other 2 So other two are as well there, other two variables are also mentioned, that is H3 and DALE. So all like IID 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all till 30, yes 33 is mentioned. Okay. And and in the next one we will be operating with the next command, that is we could have drawn the CCM as well. CCM is here. Okay, so just to regress the model we are trying to compare the equation, and we will store this, so that that is going to be helpful for us to compare. Okay. Now this is being stored in our memory. Now we will give the the conditional command with the I dot command, the way we do, since we have considered the dummy variables model. Now the result is displayed. So now we are also store the estimates of this dummy with the I command, I dot command, that we have given. I dot id is given. So it is basically comparing with the first categories of the dummy. Now this is going to give us we have already stored, we can easily compare. Now estimates will compare each of the table, that is OLS dummy, and with its star at what level this is varies, we can easily do it, and the result is on your screen. Okay. Now OLS and the dummy variables model. So how this is important and how each of these are different. You can see that in the normal OLS or with the CCM model, it has only two coefficients, and estimating with the it is similar to that of OLS model. But in case of dummy one, it estimates so many coefficients, though we have run the OLS model, but we can easily identify each of the effects differently as compared to the base category. And disadvantage about this we have already discussed. Therefore we are going to explain the fixed effect model. So fixed effect model we are now explaining. In that case we need to identify the stata with the correct specification with FE. We need to understand whether FE is specified or not. But there are some tests to understand whether it is fixed effect or random effect, that we will do it in our next class. Okay. So the exact Haussmann test, how that is significantly identifying or not, that aspect we will discuss. Let us assume that it has certain fixed effects or within effects and time variant effects. So that is what we have assumed, and based on that we have run the regression. So in the fixed effect model, the correlation is more important. The correlation between the error term and the explanatory variable is there, it is not 0. Okay. So the correlation is identifying the fact that it is in fact a model where the alpha content, actually content is correlated with the explanatory variables. Okay. So let me just explain you through the model once again, through the PPT once again, then I will come back to the discussion. We have covered all those aspects. These are the command you have to follow the way we did it. We have captured everything in the slide, and then that will help you to read between the results. Now in the within effect model, we have already clarified what is called LSDB model and what is called within effect model. And xtreg reg st reg command with finally ending with comma and fe will capture the fixed effect, and adding the robust option is going to control the heteroscedasticity. So usually there are heteroscedasticity in the model. I already told you there are it is not avoiding the problem of heteroscedasticity. In order to control the heteroscedasticity, we usually take the command called robust FE. Okay. So, streg and at the end robust FU is going to control certain heteroscedasticity to run the fixed effect model. This is how it will look like, and I'll come back to it. We have already done this. This is the one we derived, and I am interpreting through your PPT once again. And in the PPT, first aspect is that the errors are correlated with the regressions in the fixed effect model. Okay, and that is due to the fixed effect component captured in the what is called the individual effects or the constant term, and that is why it has certain correlation with the error term as well. So it is non-zero, therefore there are some problems with the model estimation. We cannot just run the run a normal ordinary least square regression. Now, second one is, if this number, that is the probability, the significance value, overall significance of the model, if this is less than 0.05, then the model is fine. Okay. Then the coefficients are interpreted the way we usually do it. This coefficient indicates, like the household the health expenditure per capita changes when the disability adjusted life expectations and the education etc. is changed by 1 unit. Okay. So, and whether they are significant or not etc. can also be interpreted accordingly. Another way to estimate the fixed effect using AREG command. AREG command, actually this is going to observe the problems and it is going to hide the binary variables for each entity. Okay. So, since binary variables are there, that is going to observe it correctly. Although its output is less informative than in regression with explicit dummy variables, since explicit dummy variables are there, AREG command is the best fit, and this does have two advantages. It speeds off exploratory work, providing quick feedback about whether a dummy variable approach is worthwhile. Second one is called when the variable of interest has many values, creating dummies for each of them could lead to too many variables or too large a model. In that case, as per the suggestions Hamilton, that you please go through the AREG command. Okay, that observes the problems with the too many indicators variables. Okay. So, that is also going to give you the result. The commands are already on your screen. You can apply on the same data. I am sure you will get it. Okay. So that we can have a comparison, let me also experiment it and going to interpret accordingly. Okay. Now we are giving you the comparison. We will run each of them, then so the fixed effect result is being derived at this moment, and we will also store this. Okay. We will also store this. So, with the name fixed. Okay. And now once again we will draw the LSDB approach with this conditional command with I.I.D, and again we will store with OLS dummy, that is LSDB regression. Then we will also compare with the try to observe the identification variable or the dummy variables. Then AREG is the command, and we will also store with AREG. Now we can, after doing so, we can estimate a table with the comparison of each of them. So, each of them now is being stored, and now you can each of them is estimated. Now you can just see the differences. So, we have all derived, the results are derived on your screen. So, let's see once. Okay. So, all three are in fact presented on your screen. This is, I think you might have understood the way we proceeded. All three are stored. First one is fixed effect. model, the command is given, then LSDB model is here. Now LSDB is also reduced or is interpreted in a better way through AREG. Okay, that has been made, and now you can see you will get the same result, okay, through the AREG. AREG and fixed effect model are going to give you when we have already captured the dummy variables problems. Okay. So, any of the model you can do it, run it, and any of these two models you can do it and estimate it. Fine. These are all for this lecture. We probably we have if any things are there, we can also explain you, otherwise yes, we can have some comparison as well with the constant common model results. It is not just the 3 within effect or LSDB effect, we can also compare with the simple regression estimation as well of the fixed effect coefficient as differences. To test that whether F is better than CCM or not, we can apply restricted F test. Okay. So, restricted F test is going to give you the direction. The null hypothesis in this case is whether alpha I is equal to alpha, because alpha is the one in case of CCM, okay, alpha is the one in case of Fe. So, whether these two are actually equal or not. So, null hypothesis is going to consider as equal. So, our hypothesis is in fact alpha is equal to alpha. If null hypothesis is not rejected, then CCM is appropriate. Okay. If both are same, then what is the point of going for a panel regression? If they are different, then of course you should go for Fe test or fixed effect model. The output of within effect model with XT-REG command conducted this F test by default. Okay. If calculated F is greater than the tabulated F, then we will reject the null hypothesis. So, this is the one that is very important. When your calculated F is different, okay, or greater than that of your tabulated F value, then of course that is going to reject the null hypothesis, and Fe is going to be considered to be better. In this case, you can see that here is the calculated value, that is 21.16, that is the F value. With the streg command, with Fe command we have given. Okay, if this is this is the one, then we will compare with the F value with its degrees of freedom with numerator and denominator values. Okay, k minus 1 in the numerator and n minus k in the denominator. The calculated value we can compare. If the calculated value are different than that of the tabulated value, then we will go for rejecting the null hypothesis. Okay. So, that next one is called testing of heteroscedasticity, that is also equally important in case of fixed effect model. We have already said that it does not avoid the problems of heteroscedasticity. So, a test is quite essential. A test of heteroscedasticity is available for the fixed effect model because of the its assumptions. Okay. So, the commands we usually give it is xt test 3, then we need to actually install it and run the xt test 3, because it is not come up with the version by default. Then we can run with the xtreg, and then this is Fe, and then at the end after the regression we need to just test xt test 3. Okay. I will do that here, but now I am just interpreting it. If that is the case, that the assumption is that should be homogeneous, okay, there should not be any heterogeneous. But if it is significant, if the p values are significant, okay, null hypothesis that the standard deviation the sigma are actually equal for all i's. Okay. But if that is significant, that means that they are not equal, so heteroscedasticity exists. So, this is what I am going to show it on the screen once, then we can go for it and explain it. Okay. So, we will install that first, SSE install xt test 3, So this is being installed. Okay. Now this is and verifying not installed. We can do it then we will now run it, and now installation is completed. Now we are running the fixed effect model in our case. So we have already run the fixed effect model, and now we are going to test the XT test 3, that is for the heteroscedasticity. Now it is confirmed to the case that our significance level, the sigma values are actually differing, or they are differing significantly. Therefore, there exists heteroscedasticity in the model. So that is another way of proving that yes, we are running the fixed effect model and it has heteroscedasticity in the model, and it is not going by the common constant model. Okay, common constant model is not the right fit when this kind of tests are identifying the heteroscedasticity. Alright, so fixed effect model is best chosen, and in the next class we will discuss about choosing between choice between fixed effect model and random effect model, and we will also give you various other dimensions of clarifying random effect in healthcare database. We will be also using ISTS data for we have also kept the ISTS data for your own reference. You can also test on your own. We have only operated through the WHO data set. If you still have some confusion, you can also refer to my earlier model. We have used ISTS data. This time we are also keeping the same ISTS data for your reference. We have operated with one database. You can operate on your own and find out the difference. The do file of both the cases have been uploaded, and that will be going to be useful for you to run it. I hope this is how you can get the best understanding out of it, and if still you have difficulties, do not hesitate and come back to us in our live session or in our chat session. Our team is quite charged to deal with all your queries. Thank you.